Hi, so we'll be presenting Magnet Madness. And our design process for our group was that of what we learned in class, and that we followed the engineering design process of ask, imagine, plan, create, and test, and improve. And though we did review share, that was not necessary in our application. So as a group, we sat down, we asked questions, and then eventually we began imagining and taking prototypes and sketches, and then eventually we began to plan our final approach, create our final approach, test our prototype, and then eventually improve our prototype to develop a final product. To demonstrate to you our project, Magnet Madness. So basically the four inputs of our game were both gravity. As you can see, this is at a 45-degree angle to the floor. Our pinball launcher, our magnet stick, there is a magnet embedded within this 3D printed part, and a magnet ball, and our vertical launcher. So the whole premise of the game is to navigate our maze, which we found to be time consuming, so that led us to the design choice of our second section, which is Flappy Bird inspired, to capitalize on the use of gravity to navigate this section as well as the magnet stick. However, once you navigate the maze, you then launch your ball, and we have marks to encourage or discourage the use of too much force on this piece. That launches the ball into our Flappy Bird section. Once that is navigated, you pick up the ball down here with our magnet stick, and you guide it up into our flip basket. And this was damaged in competition, so it doesn't work correctly. However, this would be hit, this would be flapped, and there was initially rubber band resistance provided, so that would return to its initial position. And most of the time the ball would make it into one of these scoring zones, therefore reducing your time. The whole premise of this game, due to it not being a multiplayer game, is to race against the clock. As your time is rising, you want to navigate the maze fast. And to create an incentive to this section of the game, our point system, if you will, is time reductions.
Hello there, everyone. My name is Carlos, and I'm a team member of Magnet Madness. To start this off, during the beginning of the semester, we had to ask ourselves a few questions to begin our project for the arcade game. There are four main questions that we had to think about for this project. Like what requirements and goals does the game have to fulfill? Who is this game designed for? What style of the game should we create? And can our idea be realized in a practical and timely manner? It was during this phase that one of our initial ideas of air pinball was scrapped during this phase of design due to the following reasons. The complex components of this air pinball would have created fragility with the heavy used components. And we want this thing to last. And budget would have been too much of a challenge to meet, since our main objective is to make this as cheaply as possible. And of course, it's just a large concern that this will just be impractical for all of us due to the amount of components like fans and adapters and such.
Alrighty, what's up, y'all? My name is James Thompson-Shirey. I'm a member of this Magnet Madness E101 group. Now I'll be talking about the imagine step of our engineering design process. So starting off way back in the semester when we were first coming up with our ideas, we had each of our team members individually come up with their own specific game idea, and then we met again and we would present our idea and then discuss with each other to kind of bounce ideas off and settle on a specific idea. Out of this, we had the air hockey pinball, the magnet maze, and the puzzle game. All were great ideas, but we wound up settling on the magnet maze as it just made the most sense with our specific constraints, the main one being to be done as cheaply as possible. After settling on this magnet maze, our original idea was just one large maze in which players would have to navigate to the end. Realized this was just not as fun, so that's how we settled on our 3-section design, which we wound up going forward with to the very end. Thank you.
So moving forward here, my name is Billy. I'll be presenting the planning part of our project. So initially we planned to create a 2-sided game board for one player on each side. However, down the road, we decided to just go with one side since there was no point in building the same game twice. And it was a lot more manageable on the actual creating part. So on the side, we wanted to divide it into 3 sections, one being a Flappy Bird section, one being a maze section, and one being kind of a pinball launcher section. And we wanted this game board to be completely vertical. So we did that because during our planning, we wanted to account for the FEDD project requirements, which were to have 4 different sources of input. And our four sources of input were the launchers, gravity, the spring launcher at the top, and of course the magnet throughout the entire thing. Additionally, the objective of the game would be a point-based system based on how much time it took to complete the game. So yeah.
It was at this point of the semester, after lots of time planning out our project, we were ready to actually create it. There were 3 key components that we wanted to implement into Magnet Madness. We have the outer frame, which is mostly composed of 2x4s that have been sawed and drilled together. We have the magnet stick prototype, which is a 3D printed paddle that has a little slit on the side to put a magnet, which is to help guide the ball around the maze. And lastly, we have the ball launching mechanism, where the player has to push a plunger to help flip the lever as hard as it can to launch the ball into one of the various holes at the end of the maze to help reduce time.
So we had finally reached the improvement stage of our project, and we found out that there was definitely a lot to improve. So looking at some of the design challenges we faced, a lot of it was related to scalability, because originally we had planned to have the game board be the full size of 3 feet by 2 feet. But after realizing that that was much too large, we decided to downscale to a much smaller size, and we were still able to fit all the sections that we wanted to, but we had to change a couple things like the size of the cardboard, and that also affected the radius of the base of the magnet stick that we had to reduce to improve visibility and keep the magnet thoroughly attached throughout the game. Additionally, during our improvement phase, we had to make a lot of tiny adjustments to the cardboard as we did testing, because we just found little gaps and stuff where the magnet would go over the cardboard or somehow break through. But at the end of the day, we ended up with a finished project that worked pretty well, and the bugs were pretty hard to find unless you already knew about them beforehand. So yeah. So here's just a quick view of our final product here. As you can see, it definitely turned out a lot different from our original design. However, with a lot of testing and improvising, we made it work well, and a lot of people definitely enjoyed it at FEDD Day, and we also went on to win 2nd place. So yeah, it was a great project.
What's up, y'all? James here. If I had any advice for freshmen working on the arcade game, I would say to make sure you beta test heavily. Like, test every single little corner, because we had a bunch of just random little stick points that were very annoying in the end, and could have been avoided had we beta tested better.
A word of advice I would give to oncoming members is to start your project earlier in the design phase, so that way when you run into issues with your design, it's easier and you have more time to fix it.
Now, my piece of advice that I would give to other students is to make sure that you have a backup plan, or at least some kind of outline for it the first time, and your project doesn't initially work out just like ours. Like if it's like too big or if it's just too expensive, and you always have a backup plan, so don't waste too much time trying to think of another one.
Hi, this is Baldwin here. If I were to give any advice for people starting on this project, I would say get started early, because and especially with the building, because after you start building it, you're gonna see all sorts of like little mistakes and stuff that you gotta go back and correct, and it's just good to get ahead. So start as early as you can.